Yeah, well, I think I should start right now. I don't introduce myself because I have much stuff to cover. So, yeah, well, archaeology, photogrammetry, and virtual reality. First I want to talk about archaeological documentation. I think many of you are familiar with it. Typically archaeological documentation involves sketch drawings, so pretty obvious. And as you can see, it's often very detailed. So, for example, you draw like every stone you find, every artifact, every little thing. So it's a lot of information you have to preserve, and actually that's the intention of archaeological documentation. It's to preserve as much information as possible. The best way to preserve as much information as possible is to not dig at all. That's something that's really helpful because actually excavating is destroying. It's really destroying the cultural heritage or the information, and the intention is when it has to be destroyed to at least preserve as much information as possible. So and for example in Paleolithics is like Neanderthals and everything older than like 10,000 BC. There's 1 millimeter soil can be like decades. For example, in the cave I showed, the soil is like 1.5 meters, and the time span is like 60–70,000 years. So there's a lot of information over the years, and to just preserve the information, you really excavate like little tiny steps and measure like everything you found, even small grains of chalk stone, and for example, in the demo I showed, the whole number of data sets is 90,416. So over 10 years excavation, they measured every single artifact they found, and it has a huge database. So over 9,000. Over 9,000. Yeah, a lot. That's a lot of information to keep track of. And now later we see how virtual reality can help a bit to keep track of this information. But the next thing is photogrammetry, the next topic. So I think everyone is familiar with projective geometry. It's on the mathematical basic of photogrammetry is projective geometry. So it's like perspective. Maybe you're familiar with the drawings of Albrecht Dürer. He used some lines to make drawings. Some strings to draw, and for perspective drawing. And actually, if you have many more perspectives, you can like triangulate points in three-dimensional space. So photogrammetry is almost as old as photography itself. So when François Arago showed first camera obscura to the Institut de France, he also mentioned that it could be used for measuring archaeology finds, architectural details, and well, he was proven true already in 1849 when the mathematical foundation of photogrammetry was done by Emilio Français. But the first full algorithm with 7 control points was in 1899. It was here in Munich by David Finsterwalder, a professor here at the TU Munich. By full algorithm, I mean to estimate the whole camera pose and every parameter. So external and internal parameters. So you don't have to know where the camera is positioned at. You just have to know 7 points in an image and of 2 images, and then if those points fit to the other image, you can then reconstruct the camera position of one camera and the other camera, and even the field of view and, well, on the other parameter. So, well, the use cases were really rare. So, for example, David Finsterwalder, he used it he used it for aerial, for glacier cartography. And well, it was really cumbersome to do the work. So because you have to manually measure, you have to point out the points of the image, and then it's like cumbersome handwork. And well, the use cases were really rare. So for it's used for like hundreds of years now. So for example, in architectural preservations. For example, it's much more easier to document a flat facade than it is to document a complex 3D object. So that's the use cases that were used, and forensics, where they have some sparse information from several photos, and they have to, for example, reconstruct the trajectory of a bullet, for example, and that's something. It also was used, but it was really cumbersome and not really that much popular. And well, with computer vision algorithms, it got more popular because the computer can detect points for you, like facial recognition, similar algorithms, and well, and then can match the points to other images. And so, by this, you can get a fully automated setup to estimate camera positions. And yeah, well, and GPUs can also do a lot of vector calculations. So what the mathematician had to do in cumbersome handwork, a computer can do in a blink of an eye. So for example, an NVIDIA GTX 980 Ti can do. Actually, I think I missed three digits. I think it's even more. Yeah. So it's even more than this. So 5.6 trillion calculations per second. So not sure when you did last time vector calculations. I think you all went that fast. Yeah, well, so photogrammetry and computer vision can extract a lot of information from photographs. That's also really interesting in archaeology because in most cases you have to excavate very fast. So the example I show, it's a cave excavation. It's an academic excavation, and they have many years time to excavate. But the typical excavation is like when a building is built, and then we found something. Okay. Now we can stop this longer than 2 months. No, excavate and get rid of the shit, and it's like really, you're always in short time in cultural heritage excavations or cultural heritage preservation excavations, and well, then when you can just make some photos and by that preserve a lot of spatial information because of the perspectives. It really helps. So that it become more popular in archaeology in the last 10 years, for example. It also became more popular in visual effects. So, for example, the first movie that used photogrammetry was Matrix. So the scene when Neo like falls back. They used the cameras, and because the cameras obscured the vision of the whole scene, they couldn't use a good blue screen or green screen. And by this, they reconstructed the scene with photogrammetry and they textured it. So it was like in 1999 when the first like automated texturing of the geometry happened, and then well, it got more common to use in movies, and in recent years also, like last 2-3 years, also in computer games. So just a recent example is Star Wars Battlefront. It also makes use of photogrammetry.